So, multiplying radicals. We've done a little bit of, well, not really. When we multiply radicals, you can only multiply a radical with a radical and a coefficient with a coefficient. Okay, so we're building everything on this principle right here. A root b times c root d. I multiply the coefficients, a times c, and then root b times d. Okay, so as long as they're both radicals, you can actually multiply them together. We actually have done a little bit of this. So root 3 times root 5 would be root 15. Okay, root 15. We can actually multiply the radicands together because they're both radicals. They have to also be the same index. So you can't multiply a square root with a cubic root. They're like different dimensions. Trying to, I don't know. Okay, square root of 3y cubed times negative root 8y to the 5th. Technically, what's the coefficient if you don't see it? A 1. So we have a 1 here, and what's the coefficient of the negative, the other guy? Negative 1. So when we multiply that, you get 1 times negative 1, which is just negative 1. So you're going to have a negative outside still. A positive times a negative is still a negative. And what's inside the brackets? 3 times 8, 24. Y cubed times y to the 5th. Y to the 8. We add the exponents when we're multiplying same bases. So here, when we're multiplying, right, we combine coefficients with coefficients and radicals with radicals. 5 times 7, 35, root 6. Actually, this one's right. This one's right. What's wrong with the second one? We have to simplify it. We have to reduce it. You can simplify before and then multiply, or you can multiply then simplify. It's really up to you. And we'll go through a couple examples where we'll do one way, one the other. Sometimes it's easier if you simplify it before, because then your numbers are smaller, right? So 24, what can it be broken into? 4 times 6. Okay, it's Friday. And then y to the 8th. Can you take the square root of y to the 8th? Yes, you can. So we can actually pull that one out. So square root of 4y to the 8th. Square root of 4, 2. Square root of y to the 8th. Y to the 4. Cut it in half because our index is 2. And then we have what left over? Root 6. Okay. So this actually technically would have, it would still have a restriction on the variable. Okay. Because if we go back to the original, we're dealing with a square root here. And if you look at the original that's here, if I take a negative and I cube it, will it still be negative? Yeah. And can you square root a negative? No. So still there is a restriction that y has to be greater than or equal to 0. If we look at the original question, right, these are to the power of 3 and power of 5. So if it was even exponents, okay, then there would be no restrictions. Because if you raise a negative to an even exponent, it becomes positive, right? So you're good. Okay, the restriction's already stated for this guy. Pardon me? And, oh, yes, thank you. I forgot the negative. Man, it's my brain today. All right. Good job. Thanks for catching. 3, I should give you guys something for being in class later. Okay, 3 times 2. 6. Root, and then the root 6x times 3x squared. 18x, x to the 3. And the restriction was already stated. X had to be greater than or equal to 0. Not because of this guy. That guy, you can put anything in. Because if you square the negative, it comes positive. No big deal. It's this guy that causes the restriction. Okay? because you can't square root a negative. Oddity. Can you combine these guys? What's wrong with that? Oh, let's make it larger. Oh, yes, Miss Johnson. What's wrong with my last one? Is it right? I should look at my own notes. It's right here. What did I miss to do? Reduce. Okay, so we can simplify 18 by going 9 times 2. And can you simplify x cubed? Can you square root the x cubed? If you had x squared, and then how many x's left over? Just 1. Okay, we're taking the highest, we look at the cubic, right? And we take the highest multiple of 2 from the numbers 1 to 3. Which should be 2. It's the highest multiple of 2. Okay, that gives us square root of 9x squared is a 3x. And so we're left with 18x root 2x. There we go. Now we're done. Thank you, Chase. You should just come up here. No? Oh. Can you simplify this next guy further? No. Cannot simplify further. Why not? Different indexes. So one's a cubic root, one's a square root. That's an issue. So today we get to do FOIL and distributive property with radicals. Yay! So you remember distributive property? A times B plus C would be AB plus AC. So if we had 2 times root 2 plus 1, what's 2 times root 2? How would you write that? If one's an index and one's a radical. Sorry, one's like a coefficient. There's no radical there. And one's a radical. It would just be 2 root 2. Okay? Because you can't put them together. 2 just becomes the coefficient. And then 2 times 1 plus 2. Okay? So FOIL is really an extension of a distributive property. We're taking the A and distributing into the second brackets. So multiplying it by C and by D. And then we're taking the B and distributing it in and multiplying it by C and D as well. Right? Grade 10? Everyone loved FOIL? All right. So what's root 2 times root 2? Root 4. Okay. Root 2 times 1. So plus root 2 times 1. Root 2. Anything times 1 is itself. Plus, now we have 2 times root 2. Nope. One's a radical, one's not. So it becomes 2 root 2. You just write them beside each other. And last, 2 times 1, 2. Okay, there's a few things we can do to simplify this. What are some of the things we can do to simplify this? Okay, so root 4, you can square root 4. And it just becomes just 2. Just 2. Yeah. Square root of 4 is 2. What else can you do to simplify this? Add root 2 and 2 root 2. What's the coefficient of root 2 if you don't see it? 1. So what does that add to? So we have 3 root 2's. And then we also have the 2 on the end. So this simplifies to 4 plus 3 root 2. How come we put all the coefficients together? Make that 7? Because they're not like terms. It's like if you're, because you can also imagine this as like 3x. Right? They're not like terms, so you can't. And we can't simplify that. If we can, we will, but we can't. So let's try some more. Distributive property here. Where did my number go? There you go. Okay, so this guy has a coefficient with the radical. So we have to be careful. We only multiply coefficients with coefficients and radicals with radicals. So negative 2 root 3 times 5. What would that equal? So what can I put together? The 2 and the 5. So negative 2 times 5 is negative 10. And then we just write root 3 beside it. So if you it's 5 times negative 2 root 3, you're going to have negative 10 root 3s. Okay, what's negative 2 root 3 times 4 root 7? So first, negative 2 times 4 is negative 8 root 3 times 7. 21. Can either of those be simplified? 3 can't. The only factors of 21 are 1, 3, 7, and 21. So we're done. Okay? Here, you get to turn the page. Yeah. The foil one? Uh-oh. Give me a second. Yeah? Okay, I'd like you to try too. What's wrong with Marty? I'm asking you, what's 3 times 4 root 5? 12 root 5. What is root 5 times 2? 2 root 5. And what is 4 times root 5? 4 root 25. Or you can go straight to writing just 4 times 5. Okay? Because when you're multiplying, it's basically a perfect square, right? Root 5 times root 5 is the same thing as root 5 squared, which is why it just equals 5, opposite operation. So if you want to go straight to writing just 4 times 5, you can do that. You're multiplying identical radicals. So we have 6 plus how many root 5s? 14. Or 4 times 5 gives you 20 plus 6, 26. Should have had that. Okay. I'd like you to try 4. Alrighty? Foil it out. So root 7 times root 7 is root 49, or you might have just wrote 7, and that's okay too. If you want to go straight to that. Root 7 times negative 2 root 3 would be negative 2 root 21. Then you should have had a plus 2 root 3 times root 7, it's both positive, plus 2 root 21. And last, positive 2 root 3 times negative 2 root 3. Well, the positive 2 times negative 2 is negative 4, and then root 9. So root 49, you might have gone straight to 7, and that's totally fine. What happens with our middle terms? They cancel out. And then we're left with minus 4 times, what's root 9? 3. So 7 minus 12 is negative 5 is your answer. Okay, this is a very special type of radical pair. We call them conjugates. It is a difference of squares, right? And remember, with difference of squares, back in math 10, the middle term always cancels out. And so when we have a difference of squares with radicals, the middle terms are the ones, because these will always be perfect squares when you multiply them. They're identical. So the first and the last, when you multiply them, will always turn out to be just numbers without radicals. Perfect squares when you multiply them. there will be no radical. But the middle term will always be opposite signs, and so they're going to cancel. And so these are very special, and they're going to come into play into Monday's lesson when we talk about conjugates. We rationalize a denominator that's a binomial with a radical. So these conjugate pairs, they're difference of squares essentially, okay? So if you have root a plus root b times root a minus root b, the middle terms cancel, so you only really have to multiply root a times root a, and then the positive root b times negative root b, okay? So, and then this is the other property, root a times root a is just a, which you've noticed. Okay, so this guy, is this a conjugate pair? When you have a square, what do you have to do? You write it out 2 times. Okay, you have to FOIL, right? We have to remember this from grade 10. You can't just bring the square in with a plus, you have to write it out twice. Now, this isn't a conjugate pair because it's a perfect square. They're the same. Right? Conjugate pair will always have one with a plus sign in the middle, one with a minus. They're opposite signs. These guys have the same sign. So let's FOIL it out. 3 times 3, 9 plus 3 times 5 root 2, 15 root 2. Now with perfect squares, you'll notice the middle terms will be the same. 5 root 2 times 3, you'll have another 15 root 2. And then last, what's 5 root 2 times 5 root 2? Oh, I did that already. Nope, 5 times 5? 25 root 4. There you go. So we get a 9 plus 15 root 2 plus 15 root 2. No, you don't need a calculator. 15 plus 15. 30. Plus 25 times what? What's root 4? What's the square root of 4? Just 2. So when you have a perfect square, there's going to be no radical, right? Once you're done with it. Did I push record? Yes, good. So we have 9. Well, can we go straight to 9 plus 50? Because you have 25 times 2, which is 50, plus 9. You're okay with me doing that? So adding those constants together, and there we go. Okay, couple special products. What is root 3 times root 3? Just 3. You don't have to write root 9. You can just write 3. Okay? So that's a special product. So if we had, for example, 5 root 6 times 2 root 6, well, first 5 times 2 is 10. And then what's root 6 times root 6? Or just 6x, right? Root 6x times root 6x is no more square root, just 6x. And so that equals 60x. Would there be a restriction on the variable? Even though at the very end there is no square root, you always look at the beginning. You look at both, really. Okay, if it was ever under the square root, was there any restrictions over here? No. Could x be anything, or is it restricted? Restricted. X had to be greater than or equal to 0. So if it was ever restricted at any point, it'll always be restricted. It can never become unrestricted. So let's try foiling. Now what's this? Is this one of a difference of squares? And we call them with radicals conjugate. It's a conjugate pair. It's a conjugate pair. Yay. So the result should have no square roots in it in the end. Okay. So what is root? Let's try and use our special products. What's root 6x times root 6x? Just 6x. Radical's gone. Now with a conjugate pair, technically I only have to multiply the first and the last. Because what will happen with our middle? They're going to cancel. So if I did expand this, I would have had a plus, oh, so that's a minus root 12x. and then I'm going to have a plus root 12x. And so because of that, those will always cancel. You don't have to multiply those. You can just multiply the first and the last. What's a positive root 2 times a negative root 2? Well, first of all, positive and a negative. Negative, root 2 times root 2, just 2. And so we're left with 6x minus 2. Okay. So is this guy a conjugate pair? Yes, they're identical except for the sign. Everything has to be identical except for the sign. So we only need to multiply the first and the last. What's root 13 times root 13? Just 13. Okay, positive 2 times negative 2? Negative 4. Sometimes we get so used to multiplying radicals that you're like, oh, it's 2. But because you expect it to have a radical, 2 times 2 is just 4. That happens when I'm marking tests. 13 minus 4 is 9. Really quickly, the last question, was there any restrictions on number 3? Yes, x had to be greater than or equal to 0. Yay! So, we're not done. We just have to do a little teeny bit for tomorrow's stuff. Well, Monday. Well, and it's technically not Monday. It actually is part of this lesson, but I haven't, moved it over yet. So, but this stuff you already know how to do a little bit. Because we've done rationalizing before, right? We rationalize denominators in trigonometry and in quadratics. So, let's do this. That's a little too much. So with division, we have an option to simplify first, then rationalize, or rationalize first and then simplify. I find it always simpler to simplify first, if that makes sense. So with radicals, if you had a root b divided by c root d, it's just like multiplication, where we can divide the coefficients and divide the radicals, like radicals. Okay, just like multiplication. So for example, here, 12 divided by 6, can I simplify that? Yeah, what's 12 divided by 6? It's just 2. Oh, that's not what I wanted. Try it again. 2. And then we can go root 3. Root 6 divided by root 2 is root 3. I did it again. Oh, wait. Did you drop something? Do you need help? You got it? Okay. Number 2. So same idea here. So we didn't really actually have to rationalize. We could go straight to dividing. So always check that. 24 divided by 6. 4. And then 64m cubed divided by 6m. 9m squared. Hey, is that a perfect square? Sure is. 4 times 3 and square root of m squared, m, so that's 12m. Was there any restrictions on m at any point? Yes, m has to be just greater than 0, not equal to. Why not equal to? Because you're dividing. And can you divide by 0? No. So careful of that, because it's on the denominator. We can't have m equals 0 on the denominator, because that's not possible. So the restriction's a little bit different here. A little bit more fun. This guy. What can I simplify in number 3? 5 and 10, what would that reduce to? If we divide both by 5, 1 over 2. Or you can also think of it as root 20 over 2. So you can write that as 1/2 root 20. Or you can write it as root 20 over 2. Which one do you prefer? Root 20 over 2. Okay, let's work with that one. Are we done? Nope. Why not, Chase? Simplify the radical. You can break that into 4 times 5, square root of 4 is 2 root 5 over 2, which just equals root 5. The 2's cancel. Okay, really quickly, let's see what we can simplify here. Coefficients were stacked with, there's just an 8, so we'll leave that. Inside the cubic roots, what can we simplify here? Like 4 over 18. How could we write that instead? Let's reduce that. What can we divide both of those by? 2. So this is going to become the numerator. 2 and 18 will become 9. V to the 7 divided by v squared. You have 7 v's on top, 2 on the bottom. What happens? 2 of them cancel, so you're just left with v to the 5. Okay. Now, can we simplify these further? No. We never want to leave a radical on the denominator. Okay? Ever. Now, lucky for us, rationalizing a cubic root is not in the curriculum. It's not that hard, I can show you. So we cover it more in AP. You're always going to be rationalizing square roots, which is great. Okay, you don't have to worry about. Now, to rationalize a cubic root, you could actually, I'll just do it with you really quickly. We want to get rid of the radical. And so what I'd have to multiply by is, I'd actually have to multiply by the cubic root of 9 squared. Okay, and the reason why it's 9 squared is when we're multiplying things, right, same basis, we want to add the exponents. And I want to make this the cubic root of 9 cubed. Because then the cubic root and the cube would cancel each other out. Then it would be gone. So I'm actually multiplying the top and bottom by the cubic root of, what is 9 squared? 81. Okay? So I'm just showing you this for fun, but is it going to be on your test? You're going to only have square roots, okay? So what's 81 times 2? 81 times 2. 162. B to the 5 all over, and that becomes the cubic root of 729, or just 9. Okay. So is there more simplifying we can do now? Yes, because we can pull out the v to the 5. I don't know if there's a perfect cube that goes into 162. Does anyone know? Does 8 go into 162? Oh. Check with me. Oh, here. Over 8. Nope. 27? I don't think it does. Oh, okay, 27 times 6. Nice. So let's simplify this quickly. Okay, so this becomes, we can go 27 times 6, and we can also, can we simplify the v to the 5? Yeah, v to the 3 times v squared all over 9. So the coefficient, if we take the cubic root of 27v cubed, what's the cubic root of 27? 3. What's the cubic root of v cubed? V. So we're left with 3v times 8. 24v cubic root of 6v squared all over 9. Is there anything else we can do to simplify this? One more thing. Divide by 3. 24 and 9, we can divide it by 3. 3 goes in 8 times and 3 times. Okay. 8v cubed, cubic root, 6v squared over 3. Okay. fun. So that's a cubic root, if you ever want to try one. A little bit of an extension. We've rationalized, so there's two things you need to know. We don't leave a radical on the denominator, and we don't leave a negative on the denominator. If you know those two things, you're in good shape. So they're right here, and basically that's what it says. So if I want to get rid of root 2, how did we do that in trigonometry? Multiply top and bottom by root 2. Okay, so that gives you, is that me or somebody else? 3 root 2 over, what's root 2 times root 2? 2. Done. Okay, I need to add one more here. Let's do 2 first, and I'll add a short one. Okay, what would I multiply top and bottom of here? Root 6m and root 6m. So we're left with negative root log. Are you with me? Yeah. Are you? Okay, 5 times 6m. Question? Okay, so a mole. 5 times 6m is, there you go, divided by what? Just 6m. Can we simplify 30m? What perfect square goes into 30? Does 4 go into 30? No. Does 9? Or 16? No. So can we simplify that? No. Are there restrictions on m? Yeah, there is. What's the restriction? Can't you simplify? What perfect square goes into 30? That's 32. No, I can't. M has to be a mug. Can it be a negative number? No. Can it be 0? A mug. Can it be 0? Why not? Why can't it? Why can't it be 0? We look at the original here. Why can't it be 0? Okay, your variable is where? Where is your variable? On the denominator. And so if it was 0, what's 6 times 0? 0. What's the square root of 0? 0. Can you go negative root 5 divided by 0? No. So you can't, because it's on the denominator, it can't be equal to 0. Because you can't divide by 0. Got it? All right. Okay, add one more. I think there's room somewhere, no? A little bit. Can you just go 2 root 5 divided by 3 root 7. Okay, so if I'm rationalizing this, what would I multiply top and bottom by? So that you can do 3 root 7, but you're going to make more work. You only need to get rid of what the issue is. And the only thing that's the issue is the root 7. Okay? So if it has, Jason, it's loud, stop it. Okay? If you have a coefficient there, you don't need to. You're just going to make more simplifying for yourself in the future. You just need to multiply by the radical itself. Okay? Because that's the issue. You can do 3 root 7 top and bottom, but it's going to simplify out in the end. So you're making more work for yourself. So that gives me 3 root, oh no, not 3. Gives me what? A mug? 2 root 35 divided by, or just 3 times. What's root 49? Just 7, right? Root 7 times root 7 is just 7. Okay, so we have 2 root 35 divided by 21 Can that be reduced in any way, shape, or form? No, we're done. Okay, so if you do have a coefficient on the denominator and it's a monomial, you only need to multiply by the radical. That's it. I think we could leave it here. We'll do the rest on Monday. So your assignment's on the board. It's page, I'll write it here too, 289 to 293. Numbers 1ABC, 2AB, 3AB, 4, 5ABC, and 10. So it's actually not that much. Stop.